Okay. What's rule number 1? Dane. Okay, so I'm just going to write GCF. Take out the GCF. Oh, dang it. See, I thought it was going to be perfect today. Rule number 2. Okay, it's a 2 because this works if there's 2 terms. It's the only formula that we have right now for 2 terms. If it has 2 terms, what are we looking for? It's the only one that we've got. Mason.
So are we talking trinomials, right?
Nope.
Binomials.
Binomials. We've only got one formula for that.
Are we going to try and take out the exponents?
Nope. Nope, that would be a GCF, yeah.
Perfect squares.
Close. Difference of squares. So would you write diff of squares, and you can abbreviate that however you want, and it's going to be a squared minus b squared, and it's going to factor to first one minus the second one, and first one plus the second one. So rule number 1 is take out the GCF. That's almost always going to make our work easier. Rule number 2 applies to 2 terms. It applies to binomials, and right now we've only got one formula for that. That's called the difference of squares. Perfect square minus a perfect square. That's what we're looking for. And it factors to first one minus the second one, first one plus the second one. Everybody okay with that? Okay. Rule number 3. It works for 3 terms. Okay. Do we have any formulas that might make our work quicker? Yeah. Okay. Perfect square trinomials. So perfect square trinomial. What does it look like? It starts with a perfect square. It ends with a perfect square. And the middle one is a plus 2 times the 2 of those multiplied together, or a minus 2 times the 2 of those multiplied together. And it factors to, this is why we call it a perfect square, is because it's a perfect square of the first one and the second one. And Luke, how do we tell what goes in between? Take the middle sign. So that's going to be a plus, and if it looked exactly the same, that's going to be an a minus b with the square on the outside. Okay? These are nice, quick factoring formulas, difference of squares and perfect square trinomials. They go really quick. That's why the first rule is at the beginning, always take out the GCF. And then there's a couple of fun factoring formulas that if you know these formulas, they make your work quicker. You don't have to have them memorized, but they do make it much faster. Okay? It's kind of like multiplication facts or something like that. Any questions there? Okay, if you wanted to leave it like this, you're welcome to. If you wanted to put plus the a squared and the b squared on the end, that would be fine. If it doesn't fit one of those, we're still on 3 terms. We're on rule number 3 for trinomials. It's either going to be easy or it's going to be hard. And if it's easy, that would just be an x squared plus, whatever. Okay, we'll put a bx plus c. Guess and check. Riddle method. And if it's the hard type, that has a number in front. It has a coefficient in front. Okay, and then we use trinomial grouping. And grouping means we're going to turn it into 4 terms by multiplying the a and c together and using the riddle and all that sort of stuff. So if it does fit one of those patterns and it's a trinomial, pretty quick. Maybe it's an easy one. Those are pretty quick. If it's one of these hard ones, starts off with something other than an x squared or a y squared or whatever, has a leading coefficient other than 1. Okay. 4 reminds us if there's 4 terms. Whoops, 4 terms. If there's 4 terms, what do we have to do? Dane? Group. Okay. Grouping. Okay. You can just put that on the end there. When we look at this more in depth in a couple of weeks, there is a way where we can use grouping to make it fit one of the patterns up above. And then the last rule is rule number 5. What's rule number 5? Mason. I'll start you off.
Oh,
completely. And what else? So make sure you factored, broken down everything as much as you possibly can, and include, Wilson?
I was just gonna say bring it down, like bring the numbers down.
Yeah, bring all the factors down. So include all factors. You could say bring it down if that makes more sense to you. That's totally fine. This is basically what we've been talking about for about a week now. Yeah.
so if we wanted to, couldn't we solve a polynomial any